Now we're going to graph a logarithmic function. Here are two examples of what logarithmic functions look like. The one on the left is where we have a b value that's greater than 1. Notice it's kind of the flip, kind of the reverse of the exponential graph because they are inverses of each other. So this time we're really close to the y-axis, which is x equal to 0, and then as x is increasing, we start to flatten out. In the one on the right, we have a b value that's between 0 and 1. It's just reflected over the x-axis. So now we're really close to the y-axis again, but this time our y values are decreasing as x is getting really big. The domain and range are going to be reversed from an exponential. So if you remember from exponential, our domain was always going to be all real numbers, negative infinity to infinity, and then our range was based on where that asymptote was. In logarithmic, our range is going to be all real numbers, and our domain is going to be based on our asymptote. Now first, we're just going to start with examples that don't have any left or right shift, don't have any up or down shift. All that's going to be changing is the stretch and compression. So for these situations, our domain is going to be from 0 to infinity, and our range is going to be all real numbers. We're always going to have an x-intercept at 1, 0, so that's always where our graph in these situations will cross the x-axis. And we will always have a vertical asymptote this time. Instead of horizontal, it's vertical. A vertical asymptote at x equal to 0. Just like with a horizontal asymptote, the vertical asymptote is a vertical line that the graph approaches but never actually touches. When we're graphing these, the first thing that we're going to do is rewrite it from log form to exponential. Then we're going to choose y values this time. If it was exponential, we choose x. If it's log, we choose y. Plug those in to figure out some x values, graph it, and then determine our vertical asymptote, domain, range, and in this case our x-intercept will always be 1, 0. So we have f of x equals log base 2 of x. I'm going to start by rewriting this with y instead of f of x. So I have y equals log base 2 of x. Now I'm going to change it to an exponential form. My base is 2, my exponent is y, that's equal to x. This is why we're choosing our y values. Whatever y is, that's going to determine what our x is. So in this situation, y is the independent variable and x is the dependent variable. So the y values that I'm going to choose are going to be -1, 0, and 1, just so I know what's happening on both sides of my axis. So if we have 2 to the -1, that's 1/2. 2 to the 0 is 1. 2 to the 1 is 2. When we plot these, we have an x value of 1/2, and we go down 1. Then we have 1, 0, and 2, 1. We're always going to be using, in these situations, we're always going to be using the y-axis as our vertical asymptote. That's at x equal to 0. So here's what our graph looks like. We're crossing the x-axis at 1, 0. Our vertical asymptote is at x equal to 0. It's x equals because it's vertical. Our domain this time is from 0 to infinity, and our range is from negative infinity to infinity, or all real numbers. Now we have f of x equals log base 4 of x. Rewriting this in exponential form, we have 4 to the y. I changed the f of x to a y. 4 to the y equals x. I'm going to keep those same y values that I did last time. -1, 0, and 1. 4 to the -1 is 1 over 4, or 0.25. 4 to the 0 is 1. 4 to the 1 is 4. So our points are at 1/4 -1, 1, 0, and 4, 0. Or sorry, 4, 1. Vertical asymptote at x equal to 0. And we can plot, or we can graph our logarithmic function. Domain, 0 to infinity. Range, all real numbers. Finally, we have f of x equals log base 1/3 of x. My base is 1/3 to the power of y equal to x. I'm going to keep those same y values -1, 0, and 1. 1/3 to the -1 is 3, to the 0 is 1, to the 1 is 1/3, or 0.3333, repeating forever and ever. We have the point 3, -1, 1, 0, and 1/3, 1. Now notice, this graph is going to be flipped. That's because our base, that 1/3, is between 0 and 1. So that's going to make our graph flip upside down. Our x-intercept's not changing, our vertical asymptote's not changing in these examples. Domain, still 0 to infinity. Range, still all real numbers. If you have different types of logarithmic functions, these things might change, but for purposes of this section, we're only focusing on changing the direction or stretch or compression.